Hello everyone, this is a video on the second diagnostic quiz for term 2. What I'd like you to do for this video is go to the questions that you got wrong or lost marks on in the diagnostic and watch what I'm doing and then follow along with me until you can do the questions by yourself. Okay, so this first question, we've got some surds and we are simplifying the surds. So we're thinking when we're simplifying surds, we are thinking what is the biggest that is hiding inside that surd that I can divide in. So what is the biggest square number that divides into 20? I go through the square numbers in my head and I work out it is 4. So I can rewrite that as 4 times 5. And then I do the same thing for the square root of 80. The biggest square number that divides into 80 is 16. 16 times 5. So now I've rewritten it as a multiplication. And then I can go, the square root of 4 times 5 is the same as the square root of 4 times by the square root of 5. So I can chunk it into two smaller square roots like that, multiplied together. Minus 5, lots of, same thing here, root 16 times by root 5. Now I can evaluate these square roots. I've got 3 times, the square root of 4 is 2. And I'm minusing 5 lots of the square root of 16, which is 4 times root 5. What have I got here? I've got 6 root 5, 3 times 2, minus 5 times 4 is 20 root 5. Well, now I've got like terms. I've got root 5 minus another root 5 term. So I can go 6 minus 20 gives me minus 14 lots of root 5 as my final answer. Okay, next question. Now, we're simplifying this expression. The first step would be generally to simplify the things inside the brackets as much as possible. That's already done for us in this case. So we have options. We can either raise a power to a power and go ahead and expand out those brackets, or we can sort out the negative indices first. I'm going to sort out the negative indices first. So I'm going to say that's 1 over, put the whole thing on the bottom, and change the sign to a positive, and it's divided by, same thing over here, put it on the bottom, change the sign, 16x cubed all to the power of 1. We don't need to write the 1, so we just leave it like that. Now I'm going to do two things at once. I'm going to expand out this bracket here by raising a power to a power. So that's equal to 1 over 4 squared x to the power of 2 times 2 is 4. And then I'm going to go, when I divide fractions, I go keep, change the sign to a multiply, and flip this fraction. So I'm going to be multiplying by 16x cubed all over 1. How do I multiply fractions together? I multiply the numerators, I multiply the denominators. So on the top I have 1 times 16x cubed, which is just 16x cubed, and on the bottom I have 4 squared, which is 16, x to the power of 4 times by 1. Then I can say, well, this 16 cancels out with this one, and then x to the power of 3, all 3 of those x's cancel out with 3 of them down here, and I'm just left with a 1 here, x to the power of 1. So what am I left with? I've got 1 over x. That can't be simplified any further, so that's my final answer. Next question, we're factorising quadratics. This first one, it has 2 terms. When you have 2 terms, you are either just pulling out a common factor to the front, which is the most basic type of factorising, or difference of 2 squares. We're thinking to ourselves, this is a square number, this is a square number, and they have a subtraction sign between them, so that is difference of 2 squares form. So when it's the form square number, subtract another square number, we can factorise it into the form a plus b times a minus b. So we end up with the square root of x squared, which is x, plus the square root of 49, which is 7, times by x minus 7. Next one. 3 terms, we are always going to start with the cross method when we have a trinomial like this. We're thinking to ourselves, what is the factor pair of 5? Well, there's only one, it's 5x and 1x multiplied to give us 5x squared. And then over on the other side, 2 numbers that multiply to give me 6. And when I do 5x times by this one plus 1x times by this one is going to give me positive 13x. Now I know both of my numbers here and here are going to be positive because they multiply to give me a positive and they add to give me a positive, so there's definitely no negatives involved. I'm thinking to myself, what are the factor pairs of 6? It's either 6 and 1 or it's 3 and 2. So I'm thinking to myself, if I put a 3 down here, well then I'm going to get 15x, 5x times 3, and that's already way too big. We want 13x, so we know the 3 doesn't go there. I'm thinking if I put a 2 here, that gives me 5x times 2 is 10x, plus then a 3 goes here, x times 3 gives me 3x, well 10x plus 3x does give me 13x. So that means my factors are 5x plus 3 times by x plus 2. We use FOIL to check our work. 5x squared plus 10x, plus 3x plus 3 times 2 is 6. Well, that is 5x squared plus 13x plus 6, so we know that we got it right. I'm going to come over to the side here and write my answer really clearly so it's obvious to my mark what my final answer is. So my answer is 5x squared, or 5x plus 3 times x plus 2. Next one. Again, we have a trinomial, so we are always starting by trying the cross method. I'm going to first of all start with this right-hand side because there's only one factor pair with 1, so we know the answer here is 1 and 1. Same thing again, we've got two numbers that multiply to give me a positive and add to give me a positive, so we know there are no negatives involved. We've got a positive 1 and a positive 1. Then we're thinking to ourselves, two numbers that multiply to give me 9x squared. Well, it's either 3x and 3x, or it's 9x and 1x. Now, if I try 3x and 3x, I'm noticing 3x times 1, when I do this, plus 3x times 1 does give me 6x. So, my factor pairs are 3x plus 1 times 3x plus 1, which can be simplified to 3x plus 1 squared. Okay, question 3. We've got 3 green and 2 red marbles in a bag. We're pulling out 2 marbles without replacement. So we pull one out, we throw it away, we pull out another one, we throw it away. We want to know the probability of getting 2 green marbles. Let's think about, we're in the situation where we're pulling out that first green marble. Well, currently there's 3 green marbles out of a total of 5 marbles. We've pulled that one out, it's green, we throw it away, and now we multiply, because we've now made these independent events. We multiply by, well, how many green marbles are left in the bag? There's 2 out of a total of 4 marbles left in the bag. Multiply those together, we get 6 over 20, which can be simplified down to 3 over 10. So the probability of getting 2 greens is 3 over 10. Nice easy linear equation here. What have we got? We've got 4x plus 2 is equal to, expanding out, 7x minus 28. Collect your x's on the left. Negative 3x is equal to negative 30. Divide by negative 3, divide by negative 3 to get x is equal to 10. Next question, we've got 2 simultaneous equations and we're told we are solving them using the substitution method. So I've got x is equal to 3y minus 2. I'm going to substitute that into this second equation. So 7y minus 2 lots of x, and x is 3y minus 2, substituted in there, it's equal to 8. So I've just substituted equation 1 into equation 2, and we've now got one equation with just one unknown. I can expand out this bracket. 7y minus 6y minus 2 times minus 2 is positive 4, it's equal to 8. Collect your y's on the left, numbers on the right. 7y minus 6y is y, and then subtract 4 from both sides, y equals 4. Substitute that back into equation 1. X is equal to 3y minus 2. Well, that's 3y y, 3 times 4 minus 2, x is equal to 12 minus 2 is 10. And then write your solution as a coordinate to make it really, really clear. The solution is 10, 4. Since I've done... Okay, on to the next question. We're using the quadratic formula to solve this quadratic equation. So we've now got an equation because it's equal to 0, it's got an equal sign in it, so it's no longer just an expression, and we are going to solve it and get an answer for x. So step 1, we write the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Next step, we write down a, which is 5, the x squared coefficient, b is negative 2, the x coefficient, and c, the constant on the end, is negative 6. We substitute in x is equal to negative 2 gives me positive 2 plus or minus the square root of b squared minus 4 times a times c all over 2a. So I've substituted in a, b, c. Let's simplify this. 2 plus or minus the square root of negative 2 squared is 4, and then we're subtracting a negative. We're subtracting a negative, so that becomes positive 4 times 5 times 6, which is 120. 120 all over 10. Well, this is equal to 2 plus or minus the square root of 124 over 10. Now we can go to our calculator. So 2 plus or minus the square root of 124 all over 10. Our first one is 2 plus the square root of 124 all over 10, which gives me x equals 1.31 to 2 decimal places. And now we deal with the subtract. 2 minus the square root of 124 all over 10, which gives me negative 0.91 to 2 decimal places. Next one, we're told to solve the following equation. So again, we're going to come out to an answer for x, and we've got an equation, it's equal to 0, and we are solving it by factorising. So we have to factorise it to get full marks for this question. We cannot use another method, for instance, the quadratic formula. Okay, so for step 1, we're thinking it's a trinomial, 3 terms. Step 1 is always try the cross method. What's a factor pair for 3? It's 3 and 1, that is the only one. 3x squared, 3x and x. And then again, we're thinking two numbers that multiply to give me positive 16, and when I do 3x times this number plus 1x times this number, I get positive 14x. I know that both those numbers are going to be positive because there's no negatives introduced anywhere, so it's positive for both of them. Thinking, what are those numbers? Well, the factor pairs of 16, I've got 16 times 1, 8 times 2, 4 times 4. I'm just thinking ahead a little bit. I'm thinking, if I put an 8 down here, I'm going to get 24. That's way too big, so I know that doesn't go there. What about if I put a 2 down here? 3x times 2 is 6x, and then I would need an 8 up here. Well, 6x plus 8x does give me 14x, so that one actually does work. So I can factorise this into 3x plus 8, x plus 2, and it's equal to 0. So I factorised it, but I still need to solve the equation. Now I've got this factor here times by this factor here, and the answer is 0. Using the null factor law, the only way that works, the only way you can multiply two factors together, again answer of 0, is if this guy is equal to 0 or this guy is equal to 0. Let's deal with the first one. 3x plus 8 equals 0. If you can do it in your head, then do that. Otherwise, write the little linear equation over here and solve that. Subtract 8 from both sides, divide by 3 to get x equals negative 8 over 3, comma, do the same thing for the next one. If x plus 2 equals 0, Well, you are subtracting 2 from both sides. X is equal to negative 2. Okay, let's move on to the next one. Again, it's a trinomial, so we always start with the cross method when we have 3 terms. 14x squared. What are the factor pairs of 14x squared? It could be 7x and 2x, or it could be 14x and 1x. I'm going to try 7x and 2x, just see what happens. Now for negative 9, I know I've got one negative because when I multiply a negative with a positive, that is the only way to get a negative answer. So I know that I've got one negative number either here or here, and I'm not too sure which one is negative just yet, so I'm not going to fill those in. And then my factor pairs of 9 are 3 and 3 or 9 and 1. I'm noticing that 7 times 9 gives me 63, which is quite close to what I want of 61. And then this means I'd have to have a 1 here. Now I want to end up with negative 61, so I'm thinking I need my negative here because 7x times negative 9x gives me minus 63 plus 2x times positive 1. Well, that does give me negative 61x. So I'm writing out my first factor is 7x plus 1. My second factor is 2x minus 9. And again, it's equal to 0. We factorised it, and now we solve it. We say if this factor equals 0, we picture that little linear equation in our head, or if you can't do that, you're going to come over to the side and solve it here. Subtract 1 from both sides, divide by 7. So our first solution is x is equal to negative 1 over 7, and then you do the same thing for this guy, because if we have two numbers, two factors multiplied together, the answer is 0, or one of these two factors must be equal to 0. So 2x minus 9 equals 0, add 9 to both sides, divide by 2 to get x is equal to 9 over 2 as our second solution. Final one here. Now, again, we've got a trinomial. We'd be starting with a cross method, but I'm noticing before I do the cross method that all 3 terms here have a factor of 7 in them. So I'm going to start by just taking that factor of 7 out to the front so that my numbers are nice and small, which makes it a lot easier to do the cross method. So I've factorised a factor of 7 out of all 3 terms. Now I can do the cross method just with this little bracket here. It's now monic, which makes it a lot nicer. We know we've got x and x here. What are 2 numbers that multiply to give me negative 4 and add to give me negative 3? Well, I'm thinking it's 4 and 1, and which one has to be negative? It must be this guy here, so that when I get x times negative 4 plus x times 1, I do get x negative 3x. So I've got 7 lots of x minus 4, x plus 1 equals 0. Same thing again, if this equals 0, then x is equal to 4. If this equals 0, then x is equal to negative 1. Okay, now we've got here, we're going to factorise and simplify the following expressions. We've got 4 quadratic expressions here that we are going to factorise. We are going to deal with each one individually. So top left, x squared minus x minus 12. We use the cross method because it's 3 terms, so always start with the cross method first. X and x because it's monic. 2 numbers that multiply to give me negative 12 and add to give me negative 1. Well, 4 and 3 is a factor pair with a difference of 1. Which one has to be negative? It has to be this one. X times negative 4 plus x times positive 3 does give me negative 1. So I can factorise that into x minus 4, x plus 3. We're going to do the same thing for all of these. X squared minus 49. I'm noticing I've got a minus another square number, so I'm going to use difference of 2 squares. X plus root 49 is 7, x minus root 49 is 7. Next one. 2x squared plus 15x plus 7, trinomial, 3 terms, start with the cross method. 2x times x, that is our one factor pair, and 7 also only has one factor pair. I'm thinking I'll put the 7 down here because 2x times 7 gives me 14x, and that's pretty close to 15x, which is what I want. X times 1 gives me 1x. When I add those together, I do get 15x, so I know I've got that right. 2x plus 1 times x plus 7, and we do the same thing for our very final one. 2x squared plus 7x plus 3 cross 2x and x, that's our only option, and then 3 and 1 is our only option. Again, I put the 3 here because 2 times 3 gives me 6, which is pretty close to 7. X times 1 gives me 1x. 6x plus 1x does give me 7x. So I get 2x plus 1, x plus 3. Now, I carefully put all of these in their correct position. So, this one is x minus 4 over x plus 3. And on the bottom, I have x plus 7 times x minus 7. It's multiplied by, this top one is 2x plus 1, x plus 7, over 2x plus 1 over x plus 3. Okay, now comes the fun part of cancelling out as many factors as you can. So, if a factor appears on the top and bottom, then we can cancel it out because we're multiplying and dividing by it, so they cancel out. Now, I'm noticing straight away 2x plus 1, 2x plus 1, they can cancel. Then I'm thinking to myself, when I multiply fractions, I multiply the tops and I multiply the bottoms. So this is actually, we could actually even go turn it into one giant fraction. That's multiplied by that, that's multiplied by that. What else can we cancel out that now appears on top and bottom? Well, we've got an x plus 3 and an x plus 3. We've got an x plus 7 and an x plus 7. What are we left with? We're just left with x minus 4 over x minus 7. Okay, on to our final question. So we've got two rectangles with the same area, and we are going to use algebraic methods learned in this course to determine the value of x. So what have we got? Well, we know that the area of this one is equal to the area of this one. What is the area of a rectangle? It is length times width, and this one is also equal to its length times its width. So we know that the area of this first rectangle, the length is 2x plus 4, the width is x plus 3, so its area is equal to 2x plus 4 times by x plus 3. We could do the same thing for the second rectangle and say its area is equal to its length, 3x minus 6, times by its width of x plus 5. Now, we know that these areas are equal. The question tells us that. So we know that this guy here is equal to this guy here. So let's write that down. 2x plus 4 times by x plus 3 is equal to 3x minus 6 times by x plus 5. Now, we want to solve this for x because the question asks us to determine the value of x. Remember that we can't solve quadratics unless it's equal to 0, and currently we've just got a whole big load of mess here. We need to kind of make things a bit messier initially by expanding out all of these brackets, collecting all of our like terms, and then seeing what we're actually working with here. So I'm going to expand out this left expression. I've got 2x squared plus 2x times 3 is 6x plus 4 times x plus 4 times 3, which is 12. And then I'm going to expand out the right hand side. 3x times x plus 3x times 5 is 15x minus 6 times x minus 6 times 5 gives me minus 30. Let's just simplify this a little bit. 2x squared plus 10x plus 12 is equal to 3x squared plus 9x minus 30. Now I can everything on the left hand side and collecting my like terms and set it equal to 0. So what I mean is I'm going to subtract this from both sides to get rid of it. I'm going to subtract 9x from both sides, and I'm going to add 30 to both sides. So what have we got when we do that? We've got negative x squared plus x plus 42 is equal to 0. Now I have a quadratic that I can solve. I am going to take a factor of negative 1 out to the front, just so that I don't have to deal with a negative x squared when I do my cross method. You don't have to do that, you can leave your negative in if you like, I just prefer to do it this way. So let's do our cross method. It's monic, so it's x and x. What are two numbers? When we multiply them we get negative 42, when we add them we get negative 1. Well, 6 times 7 is 42, so 6 and 7, and negative 7 plus positive 6 gives me negative 1. So x plus 6 times x minus 7 is equal to 0. So I factorise my quadratic. Now we solve from here. If this one equals 0, then x is equal to negative 6. If this one equals 0, then x is equal to 7. Now we come back up to the original problem and we think about these two different options and if they both make sense in the context of the question. If x is equal to negative 6, well, that means the width of this first rectangle, this guy here, is negative 6 plus 3, which is negative 3. And it makes no sense to have a negative length of a shape, so that means x must be equal to 7. So the way that we word that is I'm going to come up here, I'm going to say x, or I'm going to say length and width are bigger than 0, therefore x is equal to 7.